Myself, Ishwar. Once a wise man said, life is very short, my dear friend. So always be happy. From this quote, we come to know that we have to live each and every second happily. We don't know what happens the next second. So we want to live our life happily.
We are giving a worst input, say step input. For that, we have to write a equation for this. Let us assume that this is one node. This is one node A. It has two inputs only. One is this way and this way. One is incoming current and outgoing current. This voltage is V. This voltage is VC. What is voltage at A? VC. Am I correct or not? Voltage at A is VC. What is current through R? The incoming current at node A. At node A, what is the equation? What is the equation? Current, incoming current is V minus VC divided by R. Incoming current, that's why positive. What is the outgoing current at the node A? Outgoing current, that's why minus. What is the outgoing current? C dVC by dt. We know that current through capacitor. Already I told you that. If it is capacitor, inductor, voltage, current. Expression for voltage across capacitor is 1 by C integral of I dt. Current across capacitor C dVC by dt. dVC by dt. IC. Inductor means just opposite. L di by dt. Here 1 by L integral of V dt. So these four expressions you must remember. If you remember one, other three you can automatically remember. Remember one, you can easily remember all other three things. If you remember this, their voltage, if you remember always 1 by C integral of I dt. For current, definitely it must be C dV by dt. Voltage for capacitor is integral, means it must be derivative. For what? Inductor. And opposite to this is for current. This way you can remember. In that way, current leaving junction A is C into dVC by dt equal to 0. This is the differential equation. So what you can write, C dVC by dt minus VC by R equal to minus V by R. Or I can say that C dVC by dt minus VC by R equal to plus VC by R divided by V by R. This is the differential equation. Or I can say that dVC by dt plus VC divided by RC equal to V divided by RC. This is the mathematical model of the given system. Mathematical model of the system. dVC by dt. That's why VC you cannot calculate. You want to find VC. What is the voltage across capacitor after some time? Let us assume that it takes 10 seconds to charge completely. Let us assume 10 seconds. At the 5th second, what is the voltage across capacitor? That may be the question. At 5th second, what is the voltage across capacitor? That may be asked. So, how the voltage varies in the capacitor? It varies like this. Exponentially, it increases. How to find at 10th second, it completely charged. Let us assume at 5th second, what is the voltage? 5th second, what is the voltage? If you know the expression, it will be in terms of time. It will be in terms of time. If you substitute the value of time, you will get the VC. You will get VC. If you solve this, how to solve this? Mathematically, in time domain, how to solve this? The equation is dVC by dt plus VC divided by RC equal to 0. We will take first. We will find the complementary function first. Complementary function. First we will find the forcing function. This is called forcing function. Why it is called forcing function or input? This is called forcing function. forcing function. Why it is called forcing function? It forced the circuit by 5 volt. The voltage, the circuit doesn't have any voltage, but this voltage source forced to make 5 volt. The circuit voltage equal to 5 volt. That's why it is called forcing function. Forcing function or input. Or input. We can say or input. Both ways you can say. Complementary function means we have to assume input equal to 0. Complementary function. First we have to find natural response we will find. Many names in mathematics. Natural response we have to find. Natural response we have to find. Natural response or complementary function. Both are same. How to find that? For that, we have to assume that some response. That much it is difficult. Vc equal to A or C1 e power at. I am assuming that this is a solution. Vc equal to C. I can call this C some constant. No need to have only first order. That's why we can assume C. C e power at is the solution I am assuming. I do not know the value of C and A. This is a solution for this differential equation. Differential equation means result will be exponential. Already we have seen that voltage increases exponentially. Current decreases exponentially. That's why some exponential function involved I know. That's why I am assuming that the response is C e power at. I am blindly assuming that the response is C e power at. I do not know the value of C and A. Why I am assuming that e power at? It exponentially increases. That's why I am assuming some exponential function as the solution. Solution means what? If I substitute that, it must be equal to 0. What is solution? What is the meaning of solution? I am saying that C e power at is the solution to that function. Then it must satisfy that equation. Substitute that C e power at. If you differentiate, what you will get? Vc equal to C e power at means if you differentiate that C A e power at. Am I correct or not? C A e power at plus Vc. What is Vc? Vc is C e power at divided by Rc equal to 0. Take C e power at outside. What is the remaining? A plus 1 by Rc. 1 by Rc equal to 0. C e power at is not equal to 0. If it is 0, why I am assuming it as a solution? C e power at is 0 means then also it is solution. Substitute Vc equal to 0. It satisfies, but that is not our aim. We need non-zero value. We need a non-zero value. If you substitute Vc equal to 0, this is Vc equal to 0, Vc equal to 0, you will get 0. But we need a non-zero value of Vc. That's why it is not equal to 0. That's why this part is not equal to 0. Not equal to 0. Therefore, this is equal to 0. So, A plus 1 by Rc equal to 0 means A equal to what? A equal to 1 by Rc minus 1 by Rc. Therefore, Vc equal to C e power minus T by Rc is the solution. I have not yet known C value. I found A value. Complementary function I found. Now I have to go for particular integral. Particular integral is what? The particular integral is we have to assume some solution. Let us assume that the particular integral equal to, that is Vc equal to K. Let us assume. I am assuming that this is the solution. Assuming that it is the solution. V equal to what? V equal to applied voltage equal to V. That is V. Applied voltage is V. But Vc equal to K as I am assuming. So if you substitute K, Vc equal to K in that equation, dk by dt, particular integral means forced response. One is called natural response, another one is called forced response. Because it means you are applying input, forced response or particular integral. All are same. Particular integral or forced response. Dk by dt. I am assuming that Vc equal to K is the solution. I am assuming. So if we substitute that dk by dt plus Vc equal to k by Rc equal to what is that input V by Rc. Am I correct or not? It is a constant I assumed. That's why this is also equal to 0. Therefore, k by Rc equal to V by Rc. Rc getting cancelled. Therefore, k equal to V. Therefore, V is the solution. Therefore, Vc equal to k equal to V is the particular integral. What is the solution for this differential equation? Solution means Vc. Vc equal to complementary function, natural response plus forced response. That is particular integral. That is equal to C e power minus t by Rc plus particular integral is V. Vc equal to C e power minus t by Rc. When t equal to 0, Vc of t we have to write. Here, actually, what we have to write is Vc of t, because it is varying with respect to time. Capacitor voltage is not constant. Capacitor voltage is varying with respect to time. But because of laziness, we are not putting the t. Actually, we have to write Vc of t. Because of laziness, we are writing Vc. But we know that Vc is not very constant. Vc is not constant. That's why Vc of t we have to assume. When t equal to 0, what happens to this circuit? The solution now we got. Vc of t equal to complementary function. What is complementary function? C e power minus t by Rc plus particular integral is V. We got the solution. Now we have to find C also. Not yet we found the C. C we assumed. What is the C? C is assumed solution. C e power at. Already we found A. Now C we have to find. For that, let us assume that initial condition, final condition we have to apply. If you apply initial condition and t equal to 0, we know that no charge in the capacitor. That's why Vc of 0 equal to 0. We know when t equal to 0, the capacitor voltage is 0. That's why we can substitute 0 equal to C e power 0. Why? T equal to 0. At what time we are finding? T equal to 0 plus just just after turning on the switch. So Vc of 0 plus equal to 0. Initially, the capacitor is short circuit. That concept we should remember. That's why 0 volt. So C e power 0 plus V. E power 0 means 1. Therefore, 0 equal to C plus V. Therefore, C equal to minus V. C equal to minus V. Now this equation becomes Vc of t equal to C equal to what? Minus V. Minus V e power minus t by Rc plus V. Or I can say that V 1 minus e power minus t by Rc. This is the solution by time domain method. If we solve this by time domain, it will be like mathematics class. Vc of t you found. This is the answer. In mathematics class, if you are asked to solve this differential equation, what is the differential equation? This is the differential equation given. For that, this is the solution. Actually, what you are doing in mathematics class, the differential equation is, the solution means there is no number. Again, equation. But the given equation is differential equation, solution is algebraic equation. So you are converting the differential equation into algebraic equation. That's why it is called a solution. Because algebraic equation means you can find the value, Vc of t. If you substitute time value, it will give value. Only thing is you have to enter the value t. At what time? At 5 seconds. What is voltage across the capacitor? Vc 5 equal to V 1 minus e power minus 5 by Rc. If you know Rc and V, you can find voltage across the capacitor at 5th second. You can find. So that's why it is called solution to the differential equation. In mathematics class, you may wonder, solve the differential equation means again you are writing another equation. You are writing, again you are writing another equation because it is function of time. If you enter the time, it will give the answer. It will give the answer. General solution it gives. That's all. If you solve, let us solve the same equation by Laplace. How it is very simple, you can notice.